Let's talk about the real number system. Using the real number system is important to understand because we use it all the time in math class. So it's important to understand when they use these words, especially in a word problem, what do they mean? So let's talk about the difference between rational numbers and irrational numbers. Quite simply, a rational number can be expressed as a fraction or a ratio, and an irrational number cannot. So some examples of that would be like 1/3 is a rational number that creates a fraction of 1 over 3. Negative 0.5, so that could be translated as negative 1 over 2, or the decimal negative 0.5. 6 is also rational because we can express 6 as 6 over 1. We just don't normally write the 1 because we don't have to. 0 would be rational. And something like 50 over 60, even though we could reduce it, would still be considered rational because we can express it as a fraction. The other category over here all by itself is irrational. These are special numbers that cannot be written as a fraction. A very good famous example of this is pi. Pi is that number you could look at forever and it never ever ends. So that would be a very good example. You could type in your calculator. I didn't write it all out on this board because it would never end. So check on that one and see what you think. This is another example. I just made up a decimal that never ends and never repeats. For instance, 1.34279891, that kind of thing. So if on your calculator, for instance, you come up with a number, you hit math, enter, and it won't transfer to a fraction, you know that's an irrational number at that point. Another example might be the square root of 2. So the 2 looks nice, but the square root of 2 would come out as a non-ending, non-repeating decimal. So it would qualify as being irrational. So that's a category all by itself. But rational contains some other categories that are also very important for us to talk about. Integers, for example, is the most famous one. You see it in lots of problems, especially on the SAT and on the ACT. They love to use the word integers and make the problem sound really fancy and mathematical. They'll say, what is a positive, real integer? You know, that's, and they'll continue on with the problem. But they use lots of these words to make the problem sound really, really big and powerful. But integers simply means the numbers we work with a lot. They're negative numbers, 0, and positive numbers, but no fractions and no decimals. So they are rational numbers because we can write them as a fraction. We could write negative 3 as negative 3 over 1. We don't, but we can. So they are considered rational. But they are negatives, like I have listed some here, negative 3, negative 2, negative 1. But remember those little dots means that I could keep going forever and list them all the way down. We have 0 and the positive numbers, and again, I could keep going and keep going up to higher numbers. But those are some good examples. A whole number is a number, I think of like the O in the word whole, helps me remember that these start at 0 and then they count up from there. So these are included in the set of integers and they are rational, but they start at 0. They do not include negative numbers. They still also don't include fractions or decimals. So it's 0, 1, 2, 3, 4, and so on. So it's a smaller category than integers. They're still rational because you can still write these numbers as a fraction. We just don't normally write the 1 because it's not necessary. And then the last category is natural, or they sometimes call these counting numbers. They call them counting numbers because if you started counting, like I'm going to count to 10, you wouldn't start with 0, you start with 1. So that's naturally how we count. So you can remember them that way. 1, 2, 3, 4, 5, and up. So they don't include 0, they don't include negatives, and they don't include fractions or decimals. So this category is even a little smaller than whole numbers, but only by 0 is this one smaller than this category. And they are considered rational because, for instance, 3 we could write as 3 over 1. 4 can be 4 over 1. So these always qualify as rational when they're natural or counting, whole, integers, and then the larger category of rational numbers because we can put them as a ratio. Like 1 over 2 is simply rational. It's no longer an integer, whole, or natural. So let's look at a little chart with some examples. So a good thing to remember is that together rational numbers and irrational numbers form the entire set of real numbers. So let's look at a few of these together. Like 1/2, we've already kind of verbally talked about. We could rewrite it as 0.5 and look at it that way as well. So 1/2 is rational because it's definitely a fraction. But then it would not qualify as integer, whole, or natural because it's a fraction and they're not included in these categories. And it's certainly not irrational because it would make no sense for a number to be both rational and irrational. That's not possible. Then -2. -2 can be written as -2/1, so therefore it's rational. But -2 all by itself would also be an integer because it's negative, but then it's not going to be whole because remember, whole numbers start with 0 and then they go up. So it's not going to be a whole number, and then it's also not going to be natural because those start with 1. So what about 0? 0 can be written as 0/1, making it rational again. And then we could say it's also an integer because integers include negative, 0, and positive numbers. So 0 is included there. It's whole because remember the O in the word whole helps us remember the zeros included in that category. But then it's not natural because natural numbers, remember, are like naturally how we count. And we start counting with 1. It wouldn't make much sense if we're like, I'm going to count to 10. 0, 1, 2. Nobody says that. So then what about the square root of 5? I've calculated that. Let's see. That is 2.236067977. Let me write a little bit of that. 2.236067977. I checked with my calculator even, and that one will not convert to a fraction. And you can kind of tell because it just never ends and doesn't have any rhyme or reason to these numbers. That one is irrational. And then irrational would take away any possibility of these other categories. So when it's irrational, it would be none of these other ones because they are all rational. The square root of 16, we need to simplify first. That is equal to 4. So then we can tell that 4 could also be written as 4/1, making it a rational number. But then you don't want to just check off everything. Let's think about it. So an integer has negatives, 0, and positives, but no fractions or decimals. So we're thinking about just the 4 by itself would be an integer. Then whole starts with 0 and counts up. So 4 would definitely be a whole number. And natural or counting numbers are how we count. So if we start with 1 and we count up, we would definitely count up to 4. So that would be some good examples of rational and irrational numbers in the